Flack math! Give me some math and I'll give you some flack. Flack math!
So this is lesson 99. So we're going to do a little bit of review, but we're going to do exponents. But I know you guys know exponents, but we're going to do exponents of signed numbers. So this isn't as easy as it sounds. So let's just review. What does this mean? This just means 4 times itself, right? Which is 16. All right, now.
What is this? You guys, don't do that. Please stop doing that. Thank you. Excuse me.
All right, you guys ready? All right, so what if we have this? Does anyone know what this is? Yeah, what do you got, Xavier?
Negative 16.
All right, so it's negative 16. Now, what about this one? Any guesses?
Negative 16.
All right, well so this is the difficult part, okay? This one is negative 16, but this one is not. Okay, now listen to how I say this. This is, up here, this is negative 4 squared. Okay, but this is negative 4 squared. Do you hear the difference? So this is negative 4 squared, but this is negative 4 squared. I said the same thing, but it's kind of like that punctuation thing. It's time to eat, grandma. You need a comma after eat. It's time to eat, grandma. Otherwise, it's time to eat, grandma. Okay? Don't eat, grandma. All right?
Cannibalism.
So depends on how you say it. Now, this 2 only applies to the 4. This negative sign is not being squared. Only the 4 is being squared. So this is negative 4 times 4. Okay? So remember, exponents come first. So you're gonna have to square the 4 before you apply this negative sign. Now, what comes before exponents? Parentheses. So see how we applied the negative sign first, and now this is negative 4 times itself. So you're not just squaring the 4, you're squaring the whole parenthesis. So this is a negative times a negative. This is just a negative and then a positive times a positive. All right, so this negative gets carried over here. So we just get negative 16. All right, so the easiest way to remember it, I'm going to mute you just because there's sounds, Xavier, but unmute when you're ready to answer a question. So we've got negative 4 parentheses squared. So if that negative is inside the parentheses, you're going to square that negative sign, okay? But if it's not inside the parenthesis, then you're just squaring the number. All right, so an exponent applies to whatever is on the left of that exponent. The only thing on the left here is the 4. But on the left of this exponent is a parenthesis. So that means everything inside this parenthesis is squared. All right, this is one that I struggled with earlier on which one is negative and which one is positive. But think of it like order of operations. Exponent first, unless there's a parenthesis, then do what's inside a parenthesis first. Make that 4 negative first and then square it on this one. Okay, let's see if you guys can do this. Here's example 1. Give me an answer to this. So you can try this in your head. And then when you have an answer, you can shout it out and let's see if you get it right. Anybody have an answer? What was that?
You guys have one? I think they're still thinking.
All right.
I think I got one.
All right, what do you
Is
got?
the 3 squared a positive or a negative?
So that middle one, the -3 is squared. So it's not 3 squared. It's this whole thing squared because it's in a parenthesis. All right. Do you have an answer, Nathan?
I meant the 3
Yeah.
cubed.
I got -52.
All right. Good job, man. All right. So the only thing that we're going to do first, I'm going to walk through this, guys. So I'm going to walk through this. The only thing that we're doing is parentheses first. Okay. So that's the only thing we're going to do. So I'm going to copy down everything the same. So then we're just going to do -3 parentheses squared. So that means we're going to square that. So that is a 9. Because it's -3 times itself, right? So this is -3 times another -3, which is a +9. All right. And then -3 cubed. So Xavier, you asked if this 3 was positive or negative. Well, it's negative because it's subtracting that, so plus negative that, but you're going to cube it before you do anything else. But with cubes, you'll see that it doesn't matter. All right, now this guy is next. Now we're going to do exponents next, but see how we're only underlining this part right here. So the negative sign gets applied after the exponent. So this is still negative, and then 4 squared is 16. -9 minus, so see how we didn't underline that. So 3 cubed was 27. So now if I chicken scratch, because subtraction with negative signs is confusing, so chicken scratch, bok, 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 bok. Now I have 3 armies of negative that equal -52. Okay. So keep track of those negatives, do order of operations. Otherwise, these are going to frustrate you to no end. Let's do one more example and then we'll move on.
What can we do a free problem set?
All right, first one to get this gets a free problem set.
I got an answer.
All right, what'd you get?
15.
Nope.
Oh,
You can keep working if you want.
yeah. Wait.
It's hard to do these fast.
Go, Austin.
Is it -39?
Nope. All right, Xavier, you got an answer?
-37.
Nope. Keep trying, guys. These are tricky, aren't they?
Oh,
You guys seeing what you might have done wrong?
Oh, I think that, is it just like +39?
No.
is it 23?
What was your answer?
23?
23? No, it's not 23.
what?
Negative 23.
Negative 1.
All right, Xavier got it. Negative 23. See, that cute little negative sign will kill you if you forget it. All right, good job, Xavier. Now, watch this. Let's do this together, okay, guys? Let's do it real slow. We're doing parentheses first. So this whole thing gets cubed. This whole thing gets cubed, okay? So this is negative 3 times itself 3 times, right? And this is negative 2 times itself 3 times. Okay, everything else is just left alone. Don't touch it. So we get negative 27 minus negative 8. Okay, because a negative times a negative times a negative, that's 3 negatives multiplied. So that's a negative. And then this is minus 2 squared. So we're going to do that next, because exponents come after parentheses. So remember, you're not squaring the negative 2, you're just squaring the 2. So this is negative 27 minus negative 8 minus 4. All right, chicken scratch right there and right there. So then I get a 2 negatives, negative 31 plus 8, which is negative 23. Okay. Does that make sense, guys? So go slow, take your time on these. Unfortunately, math does not just require accuracy, it requires some speed as well. So when you take tests and things, you need some kind of speed. So the goal first is to be accurate and then work on your speed, okay? So you need to know how to do it perfectly first, and then you need to know how to do it quickly. All right, we're moving on to lesson 100. These are just, yeah, this is lesson 100. Pretty crazy.
So these are all 0.
And then this class becomes basically basic study hall, right?
No, I've told you like 3 or 4 times now. We're not going to. It's not going to be free days. We're going to study next week. We're going to take 2 full days to study for our final exam, and then on the following week we're going to take the final exam. Okay, so let's.
Question?
Yeah, these all.
Mr. Flack, the question is, when are these problem sets due?
So these are due Tuesday. So this is basically 97, 98, and 100 are due Tuesday. Okay, these are
Okay.
advanced ratio problems. All right, so we're just going to start with some examples. And for every ratio, there is a third number. So if I say the ratio to boys to girls in this classroom is 5 to 1, or if Xavier was there, it'd be 6 to 1, or if everyone was there, it'd be 6 to 1. So there's a third number that's implied, especially when you think about what fraction of the classroom are boys. If there's a 6 to 1 ratio of boys to girls, what fraction of the classroom are boys? Do you guys know?
6/7?
Yeah, 6/7. So there's that third number that's an implied number, which is the total. So a ratio is unlike a fraction. When I think of a fraction, I think of this much out of a total, right? But a ratio just compares 2 numbers. So a ratio of guys to girls doesn't tell you what fraction are guys and what fractions are girls. It just tells you for every 6 guys, there's 1 girl, okay? So that's a ratio, it's not a fraction. So 6/7 is the fraction. So 6 out of a total of 7. So there's an implied total. All right, so here's how I do these problems. I do these with my tic-tac-toe box, and I've got the ratio. So in this example one, the ratio of nuts to bolts, okay? So nuts to bolts was 11 to 2. Okay, so that means for every 11 nuts, there's 2 bolts. Okay. Oop, I think I did it. No, I did it right. Okay, so I've got nuts, I've got bolts, and then I've got this implied total. All right, so here's my ratio column, and I already know that that's 11 to 2. So what's my implied total here? Xavier?
13.
Right, so you just add them up. Pretty easy. Okay, so if I wanted to find the fraction of nuts, it'd be 11/13. The fraction of bolts is 2/13, right? But here's what the rest of the problem says. There are 260 nuts and bolts. Not 260 nuts, not 260 bolts, but 260 nuts and bolts. Where does this 260 go in my table here? It goes right there in the total, yeah.
Yep, they're saying total.
Okay, good job. All right, so, and then the question says, how many were bolts? Okay, so how many were bolts? That's where our variable goes. So I could put like a B right here. So now do you see my fish method here? I've got a proportion and now thank you. You've done your job. I don't need you anymore. So now I can just fish method this the rest of the way, or I can use equivalent fractions, right? 13 times 20 is 260. So 2 times 20 is 40. But fish method always works. 520 divided by 13 is 40. So 40 bolts. Okay, so see how easy this little diagram, this little tic-tac-toe box makes it? All right, let's see if we can do another one. Should we do another free problem set here? So if, I got to give Xavier his free problem set. 1 second. So if Xavier, you get this first,
Flack,
then,
in a second,
what's that?
I would like to use my free problem set on 100.
Okay, well, you have to message me that so I don't forget, okay?
Okay.
So example 2, what did you say, Nathan?
can you tell me how many points I have?
Yeah, I'll tell you after this. Remind me, okay? All right, example 2. Here we go. So if Xavier gets this, he's just going to get a couple more Flack attacks, but not a free problem set. But so the free problem set is open to you remaining guys, okay? And Michaela. When I say guys, I mean both, everybody. Okay. So here's example 2. Farmer Dunkowski, apparently that's a real name, wanted to plant his farm with wheat and corn in the ratio of 7 acres to 9 acres. So the ratio of wheat to corn, and the order of how we read this is important. So the ratio of wheat to corn is 7 acres to 9 acres. Okay, so far on my chart, I've got wheat, I've got corn, I've got total. Oh, I forgot this is a free problem set. So I'm going to let you do it. All right, here's the rest of it. If he had 640 acres, 640 acres, how many should be planted with wheat? Okay, so Xavier, if you get an answer, don't say it out loud. But if anyone else gets an answer, you can say it out loud and we will see if you're right.
I'm just gonna not go ahead and not do it.
Okay, that's fine. Thank you for your sacrifice.
Give someone else a chance, you know.
One there.
Oh, you're not supposed to use calculators.
Yeah, we can use calculators in this class.
Oh, they can?
Yeah.
Oh, okay. You got an answer?
No, I'm not gonna do it.
You don't have to use the little tic-tac-toe chart, but it does make it quite easy.
I have an answer.
Go, Andrew.
360.
What'd you say?
360.
Nope, but I know exactly what you did. Do you know what you did wrong? Anyone else have an answer?
I think I do.
What do you got?
280.
Can you repeat that, Mrs. Waite?
He said 280.
Okay, and who said that?
Austin.
All right, Austin, free problem set. So, do you know what you did wrong, Henry? Was it you, Henry, that said the first answer?
Yeah. I don't know what I did wrong.
You found the corn. Okay, so let's fill out our chart here. So this is 7 to 9, which means our total is 16, right? And that's where our 640 goes, right? So what you did, Henry, is you found this answer.
Mr. Black,
Yep.
you put you beat
Oops.
You would call too.
Okay, so yeah, who caught that?
Me and we both did it like
Austin.
Henry.
Okay. So,
Austin.
Give it to Henry.
all right, so guys, so this is what we're looking for. So we really don't need this middle part anymore. Okay. Now, what you could have done, Henry, is you could have realized this is 380. Was it 380 or can't remember? 360. 360, and then like, oh, I'm looking for wheat, and then you could have subtracted, right, to get the wheat. But this just saves you the step. You can copy, or you can do the fish method here, 640 times 7 divided by 16, or you can realize this goes in 40 times, and 7 times 40 is 280 acres of wheat. Okay, good. All right, so Henry, I am going to give you a free problem set because you corrected my math. Austin, I'm going to give you one too.
Oh my gosh, bro. Bro, you're kidding me.
That's what you get for paying attention.
Also, literally a 76 point.
No, I used to I used to do this. I have like.
Wait, Mr. Black, how many do I have?
I was going to tell you after this. Nathan, you have 10 points. So you have 2 free problem sets you could use. Okay, guys, I'm going to do one more example, and then we'll be done
I used to too.
with lesson 100. Okay? Here we go. Here's example 3. When the race began, the ratio of professionals to amateurs. So I'm not going to write down the problem. I'm just going to translate it right into my tic-tac-toe box. So the ratio of professionals to amateurs. So I'm going to say pros And then amateur, AMS, was 2 to 17, which means I have a total of 19. Okay. If there are 3,800 racers were in the race, how many were amateurs? Where does the 3,800 go? That looks like a total. Doesn't say professional racers or amateur racers. It just says racers. So that's where that goes. And then we're looking for amateurs. So that means we don't need this anymore. And here's our fish method or our implied proportion. So I'm going to use you could multiply and divide, but I'm noticing that, okay, 19 goes into 38 2 times. So with 2 more 0, that's times 200. So what's 17 times 200? Can you do that in your head?
Yeah,
What is it?
it's 3,400.
Perfect. Very good.
I did that in my head too.
Good job. All right.
That should be a free problem set.
I will, just because I'm just in that kind of mood, I guess.
Mr. Black is generous,
Mr.
bro.
Black is nice today.
Mr. Black is so generous.
What about everyone?
I had it, but I was just waiting for him to have it. Hey, I did it in my head though.
Mr. Flack, may I have a free problem set?
I already gave you a
Please.
free problem set, buddy.
May I have another one, please?
No, I'm not that generous. Okay, guys, that's about it.
Mr. Flack,
Yes.
so I have a question. So this is totally offset from math, but in the yearbook it says you could fit 20 quarters up your nose.
Oh, I don't know what they're printing these days. That's ridiculous.
No, I've actually seen it. I've seen it.
Is that really true?
I've seen it. Yeah.
Yes.
Yeah.
Yep. So guys, not many people can say that they're the best in the world at something, but I can say that. I am the best in the world at putting quarters up my nose.
How about this, Mr. Black?
Yes.
We all came
Amateur.
like 4 quarters to school on the last day and see how many like different colors we got. Like,
Oh. Weird.
If you guys bring me 20 quarters, I'll put them up my nose, and guess what? You're not going to want them back.
Yeah.
So, I'll take $5. I'll do it for
Why don't-
$5.
Why don't we do it for 25 quarters?
25. Well, I think my nose would explode if I tried to put 25 up there. All right, guys, that's it.